right, we'll do a integration, which is basically asking for the peak and what are the peak. Okay, what are the peak? Um, let me just get you ready for your week 8 anyway. You will get there. Okay, where is this hydrogen supposed to be? Did you learn this already or not? Where is this hydrogen roughly ppm? Did you learn this or not? Haven't. Okay. Okay, let's do mental exercise. This one should be roughly around 10. Okay, the things you should keep in mind for NMR. It's not week 7, but we're jumping to week 8 now. Okay, just the green stuff. If it's COOH, which I add a oxygen, this peak will be here. Okay, this one will be roughly 10, and it should be 1. Integration will be 1. All right, good? And this integration will also be 1. Okay, let me do this, because integration will be blue, so we'll use blue. Where is this peak? We'll use green, because that's week 8. Okay. Integration. Okay, 1. Okay, this one will be 1, but it's not part of the game, so we'll do later. Are we good? All right. What we have here is 2 hydrogen, right? And that's the hydrogen next to sp2, next to something. Well, it's just like something will change its ppm, change its shift. Okay, which way does it going? Okay, people are going to vote. Okay, this, change the color. Okay, we keep using this color. Yeah, just like 1, 2, 3, 4. Okay. So on your note card, it's let me say this. It will be too late when you want to solve NMR. If like, I need to check this number, those will become your common sense. I know people just love it. Trust me, that will be the case. Otherwise, in your week 8, you're going to solve a real spectrum. It's like too late. You pull out your flashcard and then check. Okay, without this carbonyl. Okay, let me do this part. This 2 part. This is without. Okay, these are without, right? Okay, this 6 hydrogen. Okay, these are without. Well, at least farther away from something that will give you, will play some effects on your hydrogen, right? Okay, this one, will roughly be very close to here, and will have a peak of 6, integration of 6. Okay, let me actually draw this peak out. Okay. Yeah. That's the red one, right? That's the red one. Yeah. Are people good with this one? Because they're.
Shouldn't the one with 6 have 2 peaks on it?
Yes, we haven't got its integration, but we will do the splitting in the next step. We only do integration. Okay. There is a hydrogen. There's a brown hydrogen. Okay. There's a brown hydrogen. So that one probably will be a little bit closer. It's only 1. Maybe I should write that 6 a lot more higher. Okay, a lot more higher. That looks like a 6 to 1. Okay. Okay, the 2 hydrogen on this. They have different peaks. Okay, they have 2 different peaks. Okay, I'll use a green and a purple. Okay. All right. If you refer to your note card, you will see a really broad range for this. It says like can go from 2 to 4 or even higher. It's like a really, so that's why your note card writes down that number. It's not really going to help you because they exist everywhere. the things you should rely on is what is next to it. So it's on. You should know there should be something around here. It's cut off. So we'll write like, okay. Let me put 4 this way. So 2 to 4. So it's not cut off because there are a lot of going on here. Okay. You should know those peak will be before we actually start to talk about splitting. Okay. Before. Okay. You should know they will be roughly higher. The reason they are roughly higher, those, and they're only one. Okay, they're only one. Based on what I post in the announcement, did you see the announcement? Announcement clarification for NMR. That's those peak. They have very specific number, right? So this is in the announcement. I post this one, and the peak of those, each of this 1, 2, 3 hydrogen have a different number, and they are actually 5-point-ish, 5.8 something-ish, right? The ppm. So that's why in your NMR, you will say, okay, there's a really rough range, there a really broad range with sp2 hydrogen. It's really just all over the place. You cannot really tell. It's for now we only care integration, okay. And then the one here in the middle. I'm run out of the color, so hopefully you can see. Okay, this one. Okay, this one is very similar to this brown one. It's next to it. It's next to sp2, and it's also okay. So we'll just put them here. So far we have not count splitting. Okay, we have not count splitting. Okay, this, okay, and this two, okay, this two. We'll find a place. Okay. Okay, that's 2. And then this one will be hydrogen. Okay. This 3 will be here. Integration. I'm just talking about integration. And this one, okay, because it's next to carbonyl, it's next to sp2. You are expecting this one to be upfilled a little bit. Downfilled a little bit, okay? So we'll be roughly here, and there's a 2. This will be, we don't think about splitting, yeah.
I'm a bit confused on why it's so downfield if it's, or upfield if it's near an oxygen.
Okay, so let's talk about the case with, that's a proton, and your proton would treat like a magnet. That's how your TA teach, right? Okay. Think about this way. Oxygen is very electronegative. Next to it, it's kind of like your magnet is strongly affected by another magnet. You're all supposed to pointing up, but your oxygen, which is another magnet, is either attract you more or oppose you more. So it's going to affect your field. The same goes to double bond. Double bond and triple bond, they are all kind of like, you have more electrocrowded, and it's gonna just like when all your magnets should point at one direction, there's another magnet just next to you. Then you're not either like just behave as before. Are we good?
So it's just too far away.
So downfield is less electron density?
Okay, treat this way. This side has nothing. This side is those things. This side has nothing. Okay? So let me actually write no splitting. Otherwise, people are going to say, okay. The whole thing here, we don't count splitting. Okay? This side, you have nothing. Move on to the middle. You have double bond. You have halogen. You have oxygen. You have nitrogen. Okay? Move to the middle. Okay? Around 6 to 7. Okay, 5-ish will be the maximum of your, let's say, things that's whatever is affecting you. Let me write sp2. Okay, sp2. That's things next to you. Will roughly all over the place from 2 to 5. 5 will be a little bit high, but things still exist. All right, 6 to 7. That's benzene ring, right? 6 to 7. Okay, then you're good. The next one will be aldehyde, will be this one. And carboxylic acid. There's nothing else you need to memorize. That's all. This is the note card. I just basically transfer it onto this. We can do another NMR next week or something. But this is your note card is not going to help you with solving a real NMR spectrum. This will be only roughly tell you, okay, this is what it is. Okay, how you solve real NMR spectrum? That's a very problem-headed. Well, which I'll think about a good way to teach, but that's next week.
Would
Okay.
that be like because the orange circled hydrogen